How's it going, guys? So, according to last week, we covered trinomials, but that wasn't all of it, because today we've got trinomials part 2. So, in today's lesson, what we're going to be doing is, last week, as you know, I discussed something like this with you. ax squared plus or minus bx plus or minus c is a trinomial in its simplest form. So, what we discussed last week was all about Mr. C over here. And we discussed that if I had a trinomial of x squared plus 6x plus 8, I would just look at my c to know that when I open my two brackets, these two signs will both be positive. Why? Well, according to last week's lesson, I said to you that if c was positive, if my c is positive, that means that both these signs inside my two brackets will be the same. We then went and said, well, how do I know if they're going to be the same? I just simply need to look at my middle term. If my middle term is positive, they'll both be positive. Then, we said that if I had x squared, we'll use the same trinomial, just to make it easy, minus 6x plus 8, again, my c is positive. So what does that mean? Well, it means that when I open my two brackets, the signs are going to be the same. But what are the signs going to be? Well, let's cast our eyes to the middle term, and it's a negative, so they're both going to be minuses. Alright, so now we've got these two examples on the board. Just to recap from last week, what we actually do is we open our two brackets, and like we just discussed, it's a positive c, and my middle term is positive, so they're both going to be positive. The front two terms are what multiplied by itself will give me x squared, well, x times x. And then we're going to look at this 8 over here. What makes 8? Well, if I multiplied 1 and 8, I'll get 8. If I multiplied 2 and 4, I'll get 8. So now we know how to get positive 8. But how do we find the middle term? As we discussed in the last episode, we need to add the terms together. So what is 1 plus 8? 9. What is 4 plus 2? 6. So if we got to make the middle term, we got to use 2 and 4. And because our signs are already there, it's nice and easy. And I'm going to show you now the same process with a negative middle term and a positive c. So again, it's going to be x and x. We know both signs are going to be negative because my c is positive and my middle term is negative. And then how do we make 8 to get the negative 6? Well, it'll be minus 2 and minus 4. And if you really want to double check, you can just multiply those brackets out. What you'll be saying to me now is that, well, those aren't the only kind of trinomials we get in tests or in worksheets or just in class in general. So yes, there are other trinomials that we can do, because what about something like this? So we've got x squared plus 4x minus 32. So this is something we haven't seen yet. All of a sudden my c over here is a minus 32. Now for those of you who've just tuned in now and you're still asking me, well, what does the c mean? This is what my trinomial is in its simple form. ax squared plus bx plus c. So my c represents that constant at the end of my trinomial. So now what do we do when my c is a negative? Well, if we open up our two brackets. Now, when we factorize a trinomial, we know that we need to put what multiplied by what gives me x squared, it will be x and x. And then we know that the negative 32, the c, is made up by multiplying the second term in the bracket by the second term in this bracket. Now, we know that in order to generate a negative 32, I'm going to have to multiply a positive times a negative. I cannot have a positive times a positive because a positive times a positive gives me a positive, and that won't give me the negative 32. So I'm going to have to use a positive and a negative in my two brackets. So this makes it slightly more tricky, because we knew that when our c was positive, that generated a positive and a positive, or a negative and a negative. So what we need to do here is, we need to say, well, how do we make 32? And in fact, how do we make a negative 32? So we can discuss that by looking at the options. So I've got 1 times 32, where one of them will be negative, one will be positive. And also I can do a negative, and this could be positive. Then we can have 2 and 16, again, positive or a negative or positive. And then I can have 3. No. Does 3 go into 32? It does not. Does 4 go in there? Yes, it does. 4 does go in 8 times. Negative, positive, negative, positive. While I'm doing this, the reason why I've done a negative and a positive for each of these options is because I need to have a negative 1 times by a positive 32 in order to get negative 32. Just to make sure you're with me. And then the next one, does 5 go in? No. Does 6 go in there? No, it doesn't. 7? No. 8? Well, I'm there again. So these are my options. And which one is going to be the one that's going to work? Well, when I look at these three options, if I had to add them together, which one is going to give me the difference of a positive 4? So to speed things up, what I'd say to you is, first ask yourself, which of these is going to generate, which of these will generate a difference of 4? So 1 and 32, whether positive or negative, is not going to generate a 4. 2 and 16 also will not generate a 4, whether it's positive or negative. But a 4 and an 8 will generate a difference of 4. So which one are we going to use? Well, my 4 is positive. So if I used a negative 8 and a positive 4, I'm going to remain in the negatives, because negative 8 plus 4 is negative 4. So because my middle term is positive, that's the sign that means that I actually need to make sure that my bigger number is positive and my smaller number is negative. So now we factorize. The answer is going to be x plus 8 and x minus 4. And now we factorize. Just to prove to you, x times x is x squared. X times negative 4 is negative 4x. Positive 8 times x is positive 8x. And a positive times a negative is my negative 8 times 4, 32. Add these together, I'm going to get negative 4x plus 8x is a positive 4x. So I've factorized it successfully. So up until now, it's been fairly straightforward. The rules we've learned have really given us an insight into how to really factorize these trinomials. But now, as we progress, and in grade 10, obviously, they want to test us more with factorizing, because in grade 9, it was just learning how to do it. Now they're really trying to test us, because now all of a sudden, we find ourselves with a coefficient of the x term. So we used to have x squared plus 6x plus 8, and we're asked to factorize that. The x was never playing any sort of role in our factorizing, besides the fact that we knew we had to put the x in the front, because x times x gave me x squared, nice and easy. And I'll just do this one quickly. It's going to be 2 plus 4. So the x, just to let you know, was not playing a massive role. It wasn't influencing the value of this 4, or it wasn't influencing the value of this 2. It was a straightforward positive 2x and a positive 4x. Now, you might not know what I'm trying to say to you, but let's look at something like this. If I have 3n squared minus 16n plus 20, I now all of a sudden find myself with a coefficient of the n squared term. Now, don't be surprised that it's an n. It could be a p, it could be a z. It does not make a difference. Any variable can be used. So now all of a sudden, if I had to open two brackets for this and go, well, how do I make 3n squared? It's not going to be n and n, because that's not going to give me 3n squared. So I now actually need to find what options I have to make 3. Well, luckily it's a prime number, so 3 can only be made one way, which is 3 multiplied by 1. So I know I'm going to have 3n and n. Some people might be asking, well, isn't it 1n because you said 3 times 1? Well, as we know, any variable standing on its own with no coefficient just means there's one of them. So there's no need for us to put the 1. For those who want it there we go, 1n. So we've got 3n times 1n, which is going to give us this 3n squared. Now, we ask ourselves, well, we knew from previous sums that it was only up to this 20 over here, the c, in order to find our middle term. But not anymore. We've now got this 3 that we need to work with. So, let's find the numbers that we can use to make 20. We've got 1 and 20. We've got 2 and 10. We've got 4 and 5. Those are my options I can use to make 20. Now, a positive 20 is made by either a positive and a positive, or a negative and a negative. Now, based on the previous examples we've done together, we notice it's a positive c. So, when it's a positive c, we cast our eyes to the middle term to see what our sign is. If it's a positive, they'll both be positive. If it's a negative, they're both going to be negative. So that saves us on that front. Now we can just focus on what we need to do. So, 1 times 20 is 20, 2 times 10 is 20, 4 times 5 is 20. But we now need to know where we're going to place either of these to get a negative 16. So this 3 all of a sudden is going to come into play. So if I said 3 times 1, that would give me 3, and 1 times 20, so that's 3 and 20. Is that going to give me a negative 16? No, it's not. It's going to give me negative 70. Let's try something else. I can't do 3 times 20, because that's going to be 60, and I'm never going to find the right answer, so we can cross that one out. Let's try the next one. 3 times 2 is 6, 1 times 10 is 10. 6 and 10, 16. Perfect, so this is going to be our match. But what's going to be negative? Doesn't make a difference, because they're both negative. So I can go minus 2, minus 10, and I've now factorized with a coefficient on the x squared term. So some of you might have thought that was a bit too quick. I really didn't understand what was going on there. So let's take another look at this one over here. I have 3k squared minus 10k plus 7. So first things first, what did we teach you about factorizing a trinomial? Well, we said the first thing we need to do is to look at our c term, because our c term can make things a lot easier for us. If we find that our c term is a positive 7, then we know that both of our signs in both of our brackets are going to be the same. What distinguishes about whether it's going to be a positive or a minus? Well, that's the middle term. If my middle term is negative, they're both going to be negative. So I can go ahead and do that. Right, now that that's out the way, I now need to focus on how I'm going to make this negative 10. So, in order to make 3k squared, alright, we know, like previously, it's a prime number, so there's only one way to make it, and that's 3k and k, because 3k times k gives me 3k squared. So, let's move on to the 7. Now, 7 is made 7 and 1. Nice and easy, because it's a prime number. There's only one way to make it, because it only has 2 factors, 1 in itself. And then 3 and 1 is how we make 3. Right, so we've finally realized that we need to say 3 times 1 and 1 times 7. So 3 times 1 means we're going to have to put the 1 over here and the 7 over here, because we know that we multiply this by the last term and this by the first term to make the 3k squared, and then this times the middle term. So 3k times my negative 1 gives me negative 3k, and negative 7 times 1k gives me the negative 7k. So together that gives me the negative 10k. So I'd like you to have a little quick go at the examples I'm going to pop on the board. Alright, so those are 2 examples I've given you to do. Have you managed to solve them? Well, let's have a quick go at them. So the top one, I'm going to have to open 2 brackets. Now, it's a little bit tricky because I don't have a positive c. I don't have a positive c. But what that does tell me is that in order to make a negative 90, I'm going to have a positive and a minus. Now, in order to make my first term, 3 is prime, so now I'm going to have 3x and x to make the 3x squared. And now it's all up to this negative 90. How am I going to make negative 90? Well, I can say 1 times 90. Now, before I carry on, I'd just like to remind you that while I'm writing all of these out, I'm constantly trying to find something, right, that's going to find me quite close to getting a negative 3. Alright, so we find that 1 times 90 is going to give me 90, but we've got the 3 and the 1 to take care of. So 3 times 1 is 3, 1 times 90 is 90. That's not going to find me the negative 3 that I'm looking for. Again, I can look at 3 times 2 is 6, 1 times 45. Am I going to find a difference of negative 3? No, I'm definitely not. And then 3 times 3 is 9, 1 times 30 is 30. Some of you might be saying, well, why aren't you saying 3 times 30 as well? But that's going to take me to 90, so that's never going to work. So again, I can just erase that. Let's look at 3 times 5, 15, 1 times 18. That looks like it can give me a difference of 3. Let's have a little look. So we said that they can each be either a positive or a minus. So let's see. 3 times a positive 5 gives me positive 15. And 1 times a negative 18 gives me negative 18. This, all of a sudden, seems to be what we need. So we have a negative 18 and a positive 15. But what did we say we times what by? Well, we said 3 times a positive 5. So where is that going to have to go? This is going to be my positive and the 5 is going to be over here. So I'm just going to switch these around quickly. And then this is going to be my negative 18. Because when I multiply it out, it's going to be 3x times x, which gives me 3x squared. 3x times a positive 5, which gives me the positive 15x. I'll just write this one out so you can see it. And then the negative 18 times x gives me the negative 18x, which then takes me to that negative 3x. I hope that one made sense to you. Alright, and last but not least, let's do the second option here. So all of a sudden we've got a bit of a bigger coefficient of our x squared term here, but it shouldn't throw you off, because what do we notice is that, again, it isn't prime, so it is a bit different, but that we do have limited options. So what we've realized is that we have to use a combination of a positive 5, these are both positive because we know that we're making a positive 15x squared. So we can throw those in here. We've got 5x and, let's give some space here, a 3x. We know that gives us our positive 15x squared. But we want to know which ones we're multiplying by which. So we realize that the positive 5 needs to be multiplied by a positive 4. So where is that positive 4 going to go? It's going to go at the back end over here. And then we obviously know that the negative 2 needs to be multiplied by the 3 to give me that negative 6x. So that when I multiply it out, I'm getting my positive 20x minus that 6x, which gives me that positive 14x in the middle. I hope that's made a lot of sense to you today.
You're still here. Still here. This is the end of the episode.
Stop making Zach all cheesy.
Just go. Go to the next lesson.